Hello class. Today we're going to be looking at inequalities that need to be solved using more than just addition and subtraction. So solving linear inequalities is very similar to what we've done with our linear equations, except when I multiply or divide by a negative number, I need to flip the inequality. So let's go ahead and actually take a look at some ones where we are just either multiplying or dividing. We're going to start out with positive numbers so we don't have to jump straight into flipping inequalities. So we'll just review what we do to solve these first. So in example number 1, the operation here that I have to start with is division. So the opposite of division is going to be, multiplication. So then I get x is going to be less than or equal to 40, which I represent on my graph with a filled in circle because I can be equal to 40. My x can also be less than 40, so I want to shade in everything less than 40, and my arrow to show that my answers can keep going forever and ever in the left direction. So this is what one problem would look like start to finish. So I need to get my x by itself and then graph my inequality. So for number 2, I am going to, the operation that I'm starting with is multiplication, so I'm going to divide to get rid of that. So divide by 4 on both sides, and I get x greater than 5. So I'm going to put 5 down as my critical number. Because I do not have the equal sign here, it's not greater than or equal to, it's just greater than, I'm going to have an open circle here at 5 to indicate that 5 is my critical number, but I don't want to include 5. And then I do want to include all of the numbers that are going to be greater than 5, so that's over here. So these are my numbers greater than 5, and again I want to include my arrow because I know that those numbers can keep going on forever and ever and ever in the positive direction. So my solution set here, anything that will work for me to put in for my x value here, is what I have shaded. So I can't put 5 in because then I'd get 4 times 5 is greater than 20, and 20 isn't greater than 20. But I can start with everything to the right of 5. So I can put in 4 times 5.00000001, and because that number is just ever so slightly to the right of 5, it will work in this inequality, giving me a value greater than 20. So looking at problem number 3, this offers us a unique opportunity to look at how can I get rid of fractions. Well, here my operation is division to start with, so I can multiply by 4 on both sides. This is also a good technique to get rid of my fractions in general. So if I multiply by my common denominator, I can in essence get rid of the fractions in my inequality or equation. So let me get my notation down here. So dividing by 4 and then multiplying by 4 will just leave me with an x on the left because these are opposite or inverse operations. the division by 4 and multiplying by 4 are inverse operations. And then now I need to know how to deal with my 1/2 times 4. Well, I can show that. Let's do that off to the side. Sometimes if I have my fractions that I'm trying to deal with in a equation or an inequality, sometimes I like to do this just off to the side here so that I can kind of keep this fraction work separate from my equation work. That's just kind of how my brain works. So I have 1/2 times 4 that I want to take care of. In order to do that, I'm going to put my 4 over 1. See if I can get that to happen. Notation is correct. Now that I have my 4 placed over 1, I can go ahead and just multiply straight across, so I get 4 on the top and 2 on the bottom. And that, of course, simplifies to just 2. 4 divided by 2 is 2. So here, I'd get x equals 2. Another way that I can think of that is 1/2 of 4 is 2. So I'm going to go ahead and graph my critical number, which is 2. Oh, I lost my inequality sign. So I had a less than symbol. I want to carry that down, not an equal sign. And then because I don't have an equal, it's just less than, not less than or equal to, I'm going to have an open circle, and I want to be less than, I want my x values to be less than 2, so I'm going to shade to the left. This is, again, going to represent all of the numbers that I could put in for x that would make this inequality be true. So we're going to leave some of these to do as a group. And let's go ahead and take a look at what this looks like if I am either multiplying or dividing by a negative number. So for example, number 7, here my operation that I have with my variable is a division. In order to get rid of that, I'm going to multiply. So I'm going to multiply by a -2 on both sides. Let's not use my x. That can get confusing with the other variables. Try my best to draw a little dot here to represent my multiplication. Not a great one. There we go. So if I multiply 2 by -2 on the left, a division by -2 and a multiplication by -2 just cancel out. They leave me with an a on the left. And 5 times -2 gives me -10. That part was pretty straightforward. Now I need to figure out what I'm going to be doing with my inequality. Well, we had said earlier up here that if I multiply or divide by a negative number, I need to flip my inequality. Well, what does that mean? I just need to go from a less than or equal to a greater than or equal to. So now I'm going to still graph my critical number, which is -10. I do have an equal sign, so this is going to have, I have a greater than or equal. So since that includes an equal part, I'm going to include the number 10, or -10 rather, in my solution set. So -10 works. So I'm going to fill in that circle, and then I want all of the numbers now that are where my a values are greater than or equal to -10. So that is coming over here to the right. I do want to save these other problems here for our work during our Google Meets. And then you guys are going to be doing homework EI2b. On Thursday this week, you are going to be taking a quiz over our inequalities. Please come to class with questions. I would like for you, before our Google Meets, I would like for you to try the problems in this EI2b notes that we didn't try here in this video. I'd like for you to go ahead and try those on your own, and then we can talk about those, make sure you understand those, and I will be calling on you to complete those as a group, and then you can do the homework after our Google Meets is done. Have a great afternoon.